Summer 2026, Shenzhen. The temperature outside is 41 degrees Celsius, the kind of heat that bends the air, the kind of heat that used to shut cities down. Walk into a tower in the Shanghai district right now, and it is cold. Not warmish, not the AC is trying. Cold? Office workers are wearing jackets in July. Now look up. Look at the roof. Look at the walls outside every window. There is no air conditioning unit. Not one. Not on this building. Not on the next one. Not on the next 50. Somewhere, underground, something else is doing the work. Something you cannot see, cannot hear. And until 7 days ago, almost nobody outside of China knew existed. This is the story of how an entire city stopped fighting the heat one room at a time and started fighting it as a single machine. And by the end of this, you will understand why the rest of the world is about to copy it whether it wants to or not. For 70 years, cooling a building meant the same thing everywhere on Earth. You buy a box. You bolt it to a wall or a roof. It hums. It drips. It eats electricity. And it cools one room or one floor or one building and nothing else. Multiply that by a city. 10 million boxes, 10 million compressors, 10 million motors, all switching on at roughly the same hour of the same afternoon, all pulling from the same power grid, all fighting the same fight in isolation from each other. Nobody designed it this way on purpose. It just happened. Building by building, purchase by purchase, decade by decade, until entire nations were running an invisible parallel infrastructure made of nothing but individual machines that never once talked to each other. And for a long time, it worked, until the heat stopped playing by the old rules. China's summers are not what they were 20 years ago. Heat waves now arrive earlier, last longer, and hit harder. And when they hit everyone at once, homes, factories, hospitals, ports, all reaching for power in the same 3-hour window every single afternoon. That is the moment the grid starts to bend. Not break, not yet. Bend. Because a power grid is not built for 10 million machines to scream for electricity in the same 60 minutes. It is built for an average, and heat doesn't care about averages. Heat is a spike, a wall, a demand that arrives all at once and does not negotiate. Every air conditioner in every city on Earth is quietly betting that the grid will hold. China stopped making that bet. So somebody asked a different question. Not how do we build more air conditioners? But why does every building need its own machine at all? Think about water for a second. You don't have a well in every apartment. You don't have a private water tower on every roof. Water gets made in one place at scale, efficiently, and then it's piped to wherever it's needed. Nobody thinks that's strange. It's just infrastructure. So why is cold different? That question is the entire story, because the answer China landed on has a name, and it is quietly rewriting how cities survive heat. District cooling. Here's the idea stripped down to its bones. Instead of 1,000 buildings each running their own compressor, you build one massive plant. A cooling factory. It produces enormous volumes of chilled water brought down to a few degrees above freezing, and it pushes that water through a sealed network of underground pipes out to every building connected to the system. Inside each building, there is no compressor anymore. No noisy unit on the roof. Just a heat exchanger. A simple device that lets the chilled water absorb heat from the building's air. The building never touches a drop of that water. It just borrows the cold. One plant, one system. 10,000 buildings, cooled like it's one machine because now, technically, it is. This is not a lab experiment. This is not a pilot project running in one office park for a press photo. The flagship station in Shenzhen's Shanghai Cooperation Zone is right now the single largest district cooling plant in Asia. It already serves roughly 2.75 million square meters of building space. That is not a typo. That is a small city's worth of floor space, being cooled from one centralized source. And Shanghai isn't finished. The plan is 10 of these stations working as one network, expected to save around 130 million kilowatt hours of electricity every single year, while cutting out roughly 130,000 tons of carbon dioxide annually. To put that in perspective, that's the emissions footprint of tens of thousands of cars gone. Not because anyone stopped driving, because a city stopped cooling itself the wasteful way. And Shenzhen is not alone anymore. In Guangzhou, engineers are building an integrated energy project for the city's financial district, a development expected to eventually cover 8 square kilometers, fed by 8 centralized energy stations working together, delivering more than 200,000 refrigeration tons of cooling capacity through one connected grid. This isn't a fix for one building anymore. This is a blueprint for a species learning to survive its own climate. Now here's where it gets clever, because building one giant chiller isn't actually the hard part. The hard part is timing. Electricity demand isn't flat throughout the day. At 2 in the afternoon, when the sun is at its worst and every office and mall wants maximum cooling, the grid is under maximum stress, and electricity is at its most expensive and most scarce. At 2 in the morning, almost nobody wants power. The grid is quiet. Electricity is cheap. So what if you didn't need to make your cooling in the moment you need it? What if you could make it hours in advance and just store it? That's exactly what these systems do. It's called ice thermal storage, and it sounds almost too simple to work because it is simple. Overnight, while the city sleeps and electricity is cheap and the grid has room to breathe, and the plant runs its chillers at full power and freezes enormous tanks of ice. Then, the next afternoon, when the heat peaks and the grid is straining under the weight of an entire city demanding power at once, the plant doesn't need to run flat out. It just melts the ice. That stored cold gets released straight into the network, cooling buildings without pulling anywhere near as much power from the grid during the exact hour the grid can least afford it. You are, in effect, moving the hardest part of the job to the middle of the night, when nobody's fighting over electricity, and cashing it in during the day when everybody is. It's not just a cooling system anymore. It's a strategy. A way of making tomorrow's crisis show up at an hour when nobody's around to be hurt by it. And they didn't stop at ice. Some of these networks are now pairing with ground source heat pump systems that reach down into the earth itself, where the temperature stays stable and cool no matter what the surface is doing, and pull that stability up into the cooling loop. Others are using reclaimed water that's already been used once by the city instead of fresh water, cutting down on freshwater consumption in a country where water stress is already a real and growing problem. Layer by layer, what started as let's build one big air conditioner has quietly turned into something closer to a nervous system. Sensors, storage, timing, multiple cooling sources feeding into the same loop, all managed by software that decides, minute by minute, where the cold should come from and where it needs to go. No single building in this network is smart. But the network is, and that is the real shift here. Not the pipes, not the plant, not even the ice. The shift is that cooling stopped being a product you buy and became infrastructure you belong to. Here's the part that should actually unsettle you a little. This isn't just happening in Shenzhen and Guangzhou because those cities are unusually hot. It's happening there because those cities got unusually serious, fast, and the rest of the world hasn't caught up yet. Most cities on Earth are still building the old way. One box per room, one compressor per floor, one grid straining under 10 million separate uncoordinated demands every single summer, getting worse every single year. And the honest truth is, most of those cities can't just flip a switch and become Shenzhen. District cooling needs upfront investment most municipalities haven't budgeted for. It needs pipes under streets that were never designed to have pipes put under them. It needs political will to think about cooling as a 20-year infrastructure project instead of a customer buying a unit at a hardware store. Which means, for a lot of the world, the choice isn't really old system versus new system anymore. The choice is adapt now, while it's a decision, or adapt later when it's an emergency, because the heat is not slowing down. Every year the peak gets higher. Every year the grid gets pushed closer to its limit. And every year that a city delays rethinking and how it cools itself, it's betting its entire summer on 10 million machines, all holding the line at once. One city figured out that if you're going to fight a heat wave, you don't send in 1 million soldiers fighting alone. You build an army with one commander and a plan. The rest of the world is still sending in the 1 million soldiers. The only question left is how many more summers it takes before everyone else runs out of other options.